Now we're going to take a look at some special functions. So first off, notice that for any real numbers, a, b, and c, we have something called a constant function. And on my calculator, I'm going to graph it, y equals 3, the one that's underlined. And notice it's a horizontal line. So a constant function is a horizontal line, and it is a polynomial of degree 0. And in this particular one, it's a horizontal line through y equals 3. On the next one, we have a linear function, ax plus b, and it's a polynomial of degree 1. So we're going to graph this line, y equals a negative 2x plus 5. And from our previous classes, we know it has a slope of negative 2 and a y-intercept of 5. So on my calculator, negative 2x plus 5, and we graph it. There it is. Notice the y-intercept right there at 5. So we're good with those two special polynomial functions. Let's take a look at the quadratic functions. Quadratic functions have a lot of properties. So first off, a quadratic function is a polynomial function of degree 2, and the general form is something that you should be familiar with, ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0, and that makes that degree of 2 keep working. So on this part, example 5, let's identify b and c are not there, so we're just going to say they're equal to 0 on part A. On part B, a equals 5, b equals negative 2, and c equals 0. A is a number in front of x squared, so on part C, a equals 4. B is a number in front of x, so b equals 0, and c equals 7. And then on D, a equals negative 6, b equals 7, and c equals a negative 3. So something that y'all have seen before. Let's talk about those properties of this guy. The key characteristics of our functions. First off, the domain is negative infinity to infinity. All x values can go in. It makes a U shape, and it's called a parabola. If the a value is positive, greater than 0, it opens up. And if the a value is negative, it opens down. The vertex is where it turns at. It's called the maximum or the minimum, depending on if it's opening up or down. And it's denoted by the letters H, K. H can be found with that formula, and that will give you the x value. And then y can be found with that formula, and that will give you the k value of the vertex, or the y value of the vertex. All right. So looking at our graphs down here, notice how that matches those things that we just went over above. So it says that a parabola is symmetric with respect to a vertical line, x equals h. And that line I'm drawing there, that's x equals h for that parabola. And notice it's a line of symmetry. The range of a parabola is given this way. If it opens up, it's from the y value of the vertex to infinity. If it opens down, it's from negative infinity to the y value of the vertex. The y-intercept is a constant. When you plug a 0 into that, you get that constant at the end, which is c. And the solutions happen when you set the equation equal to 0. And for that reason, it's called the zeros of a quadratic function. And we have at most 2 zeros. And above, we have some graphs that show the type of zeros that we have. So on the first graph, there aren't any zeros. On the second graph, there are 2 zeros for each function. And then on the third graph, there's only 1 0, although that 0 is repeated. So, it gets a little iffy there. We'll talk about that later when we do complex multiplicity. But we don't deal with our complex zeros right now. So on the first one, once again, there are no zeros because it doesn't cross the x-axis. There's no real zeros. Second one, once again, 2 zeros. And the third one has 1 real 0 that repeats. Okay, and you say, why does it repeat? Don't worry, we're going to talk about that in another section. So examples 4 and 5, we're going to do all 8 properties. All of them. So here's the 8 properties. Now let's get started. I'm just going to I'm going to look at the function first. And I'm going to say it has a negative x squared. A is negative, so it opens down. So a is negative 1, b is 4, c is negative 3. So the direction opens down because a is less than 0. I can find the vertex using those formulas. H equals negative b over 2a, which is negative 4 over 2 times negative 1, which is 2. And then k is f of 2. So if I plug 2 in, I'm going to get an h value of 1. So the vertex is at 2, 1. It opens down, so that's a maximum. The line of symmetry is x equals h, which is x equals 2. So there's a nice little picture of our vertex in our graph. And it's going to go, the range, the y values are from negative infinity to 1. And 1 is included. So make sure you put that bar, that hard bracket there. The y-intercept is at the constant. So f of 0, when we plug in a 0, gives us a negative 3. So the y-intercept is at 0 for the x, negative 3. And the zeros of the function happen where we take the whole thing and set it equal to 0. And there's a few ways we could do it, but the calculator is a quick way. So enter in your function into your calculator. Then once you hit graph, go to second calculate, and you're going to find the zeros. All right, our zeros are roughly right there. Okay, there's our zeros. So second calculate, choose number 2, and then left bound, right bound, which is really saying below the x-axis, above the x-axis, yes. And we get x equals 1 as a solution. Do it again. This case is going to be above the x-axis, below the x-axis, take a guess, and we get x equals 3. So our zeros are at 1, 0, and 3, 0. And this information here, I can graph this on this little grid on the top right of the page. So let me fill in the domain in the graph, and now we're going to graph it. So starting off, as we graph it, I'm going to put in the x values, the zeros, where it crosses the x-axis. I'm going to graph the vertex at 2, 1. I'm going to graph the y-intercept at 0, negative 3, and I'm going to connect those points. And there's my graph. On example 5, let's take a look at it. A is positive in this case. A equals 2. So I know it's going to open up. Put it on my calculator. There it is. So let's fill this stuff in. The domain is from negative infinity to infinity. It's a U-shaped parabola. That's one of the properties. The direction is up because A is positive. A equals 2, B equals 3, C equals negative 2. The vertex can be found several ways. We can say H equals negative B over 2A and plug in our values. Or we can go to our calculator and say, since it's opening up, we're looking for a minimum. So left bound, right bound, enter. Our minimums is wonderful decimal, which I'm going to write as negative 0.75 for the x value and negative 3.125 for the y value. To check that, to show that the math works out, let's plug in our numbers. B is equal to 3, so the opposite of 3 over 2 times 2 equals a negative 3/4, which is a negative 0.75. Plug in that value for y, f of x, plug it into y, and we get this, which I'm going to say, well, yeah, let's use our calculator because that's not right. Negative 0.75 squared, not 2 times negative 0.75. I got that square there. I didn't write it down on my page. So let me use my calculator. 2 times a negative 0.75 squared plus 3 times a negative 0.75 minus 2 is a negative 3.125. Exactly what we got when we ran that second calculate minimum function on the graph. So there's H and K. Now the line of symmetry happens at H. It's a vertical line. So x equals H. X equals a negative 0.75 or negative 3/4. The range of this thing, it opens up. So it's got a minimum. It starts at the y value of the vertex. So it starts at negative 3.125 and it goes to infinity. The y-intercept is when x equals 0. It works out to the c value. If I plug a 0 into my function, I get a -2. So the y-intercept is going to be at 0, -2 on the y-axis. And then the zeros happen when the whole function equals 0. So you can factor it, or you can use your calculator. I'm factoring it very quickly. The factors of the leading coefficient and the constant, such that you get that +3 in the middle, works out this way. And if you don't like factoring, that's okay. We don't have to factor. You could do the quadratic formula, which we'll talk about in another video, or you could use your calculator. So if we do our calculator, second calculate above the x-axis, below the x-axis, guess, and we get -2. Do a 0 again. This case is going to be below the x-axis, above the x-axis, guess, and we get that 0.50. So we have all of these qualities of a parabola. Now we're going to graph it. I'm going to start with the y-intercept, 0, -2. And then I'm going to graph my x-intercepts, 0.5 and -2. And it's kind of whopper job, so I'm going to take a moment here and I'm going to get that line of symmetry with the putting in the vertex. There we go. That's a little bit better. So once again, just using the information from these characteristics, I can graph this quadratic without having to use my calculator to graph it if I wanted to just do it by hand.